All right, good evening, everyone. Happy Friday. Happy Friday evening. Tonight we're going to do something a little bit different. For this video, we're going to use yet again another new resource, and that's going to be subnetting.org, which has a bunch of subnetting challenges that we can use to practice subnetting. As you can see, I'm on video this time. And the reason for that, I might actually be on video going forward, just to kind of make it a bit more personal. But the reason for that is that when I do subnetting work, I like to have my trusty little dry erase board. And we'll talk about what these numbers mean in a moment. And I want to be able to show that to you all, how I go through these problems. So I'm going to go ahead and erase everything on here because I need a bit of practice kind of organizing this. When I take the CCNA, I plan to do it in person and not online. And so therefore my belief is that in person you can have something like this, and then you can just write by hand, which I prefer for stuff like this. You might see why in a second. So anyway, happy to see everyone. I think we're up to 5 subscribers now, one of whom is my mother-in-law, so hi Loretta. So let's get started. So I'm going to go to subnettingpractice.com, and as you can see on Subnetting Practice, there is just a bunch of subnetting practice. So my plan tonight is to go through some of these, see if I can get some correct, talk about my thought process, how I work these out, and I like to use this function whenever I get one wrong. So, I'll work out a solution, and then if I get it wrong, I like to click this button so I can only get this type of question going forward until I can consistently get them correct, and then move on to a different style question. So subnetting is going to be obviously a important part of CCNA training, and just an important part of IT and of networking in general. So it's very important to have good fundamentals when it comes to subnetting. And subnetting is the process by which we break a network into smaller parts. We compartmentalize a network, we break it into smaller parts, and we can use variable length subnets to break networks into various sizes of smaller parts. Okay, so not every subnet needs to be of equal size. You can have in your network a subnet that is larger than another subnet that is smaller, all the way to the point where you just have 2 hosts, or like a single host running in a subnet. That's possible, or you could have, I don't know what the actual max is, I can't remember off the top of my head, but you can calculate it. So anyway, there's that. The first thing I'm going to do, this is what I would do for the CCNA, and until I can just like memorize this in my head, this is what I would do if I had to do subnetting type work in the field. That's to write out my kind of safety net, my subnetting little safety net, and I'll show you what I mean in a second. So I'm going to go ahead and write that out. Along the top row here, I'm writing the values, and this of course has to do with binary, but 128, 64, 32, 16, 8, 4, 2, and 1, like so. Okay. And then down the left side, I do 128. And then essentially, starting with 128, I'm just adding to the right the different values. So 128 plus 64 is 192. 192 plus 32 is 224. 224 plus 16 is 240. 240 plus 8 is 248. 248 plus 4 is 252. 252 plus 2 is 254. And 254 plus 1 is 255. So my little cheat sheet ends up looking like that. All right, and I'll use that for various purposes as we go through these. So the first one, here we go. The following shows a router on a stick scenario. Given the partial show run command information from the router, okay, so let's look through this. So from interface fast Ethernet 1.2 encapsulation .1Q2, its IP address is 192.168.0.1 with a subnet mask of 255.255.255.128. All right, sounds good. The second is the 1.3 interface, and that's some IP address with some subnet mask. Okay, and then the following is a third one, 1.4. You plan to add two new VLANs, VLAN 5 and VLAN 6. VLAN 6 should support 46 hosts. No, VLAN 5 should support 46 hosts, while VLAN 6 should support 27 hosts. Which of the following answers makes sense? For your answer, simply give the letter of the correct choice. Okay, so I need to add two new VLANs, VLAN 5, which should support 46 hosts, and VLAN 6 should support 27 hosts. All right, so if I want to add one, I'm looking through these. So we've got 192.168.0.244. All right, 192.168.1.1, 192.168.0.189, 192.168.0.247. All right, so let me think about this for a second. First of all, what I notice about the first three that already exist, everything has a subnet mask where the first three octets are set to 192.168.0. All right, so I think in order to add an additional two subnets to this network, we would mirror that with our answer, because adding a different value in the third octet would be a totally different subnet, and we wouldn't be adding I guess we would be a different network, I should say. We wouldn't be adding subnets to the same network if we had a different value in the third octet. So I believe what that means is we can immediately eliminate option B, because as you can see, option B has a different value in the third octet. All right, so that's a 1 there instead of a 0. So I'm not going to work with that. All right. Now, for the remaining others, let's see how much or which space is already occupied. All right, so for the first one, like, what is the range of hosts that is occupied by this IP address, or by the subnet that this IP address exists in? All right, so because it is a .128, all right, the way I work with this is I just put a little dash right there for .128. Okay, so that's what I see up there. Okay, so anyway, what this tells me is that, first of all, down the left side, I have basically a subnet mask that I can use, and it's already given to me in this case. Along the top are the ranges, or there's probably a better term, but like the number of the blocks, the block size of hosts. All right, so for this first IP address, it is in a subnet that has a block size of 128 hosts. And what that tells me is that this subnet goes from 192.168.0.0 to 192.168.0.128. All right. So that's the range, 0 to 128. So we know that in this subnet, the first interface is occupying hosts 0 to 128. Now, 0 would be the network address, which isn't a usable host. And that's why I believe that this interface has been assigned the .1, because that's the first usable host in the subnet. The .128 is also the 128th host, also not usable because that's the broadcast address. So the last usable address, I believe, in this subnet is .127, just for future reference. We'll probably get a question about that. Okay, now, Fast Ethernet 1.3, what does it occupy? What's the range? So it is a .192. And so in that case, for .192, I just put like a tick mark for the two values that add up to 192. All right, so it ends up looking like that. And this is probably kind of cryptic, the way that I use this. You probably really can't even see it, but this is just sort of the method. And I learned this from this book, Cisco CCNA in 60 days. So it's just a little device that I use that I took from that book supposed to be making subnetting quicker. I don't know if that's really the case for me at this point so far, but anyway. So for a .192 subnet mask, which is what we've got here in the fourth octet, we've got 2 down and 2 across, and those always need to be equal. Okay, so 2 little ticks over, 2 little ticks down, and the furthest right little tick shows us the block size of the hosts that we have. So in this case, we've got a block size of 64. And so as we said, the first interface occupies a block size in the subnet of 128 hosts. So it goes out to 128. The next one will be a block size of 64. So that's going to be 129 to out to whatever 129 plus or 128 plus 64 is. And now 128 plus 64, 8, 9, 10, 11, 12 is 192, which we actually already had right there. That was pretty practically given to us. All right, so this is going to go from 129 to 192. Okay, so we've got, I'll rewrite this, and actually, what is it? My kids wrote on the back of this. It's probably what you're looking at. I'll rewrite this nicely in a moment. So I know the block size for the space occupied by interface 1.3, or at least the IP address that the space it falls in. So we've got 0 to 128, 129 to 192 occupied. And now we've got another one, 1.4. It also has a .192, and it starts at 193. And because, again, it's the same subnet mask and the same sort of tick mark little system, 193 to 64. It's got a block size of 64, so I'm going to do that real quick. So let's see, 193 plus 64, 7, 9, 15, 256. All right, so 192 plus, so it goes all the way out to 256. And that's kind of interesting. Am I going to get this right? Because 256 is like the full blocks, is the full available size that is possible. All right, so 193 out to 256. So let me just rewrite this. So we got spaces occupied currently is 0 to 128, 129 to 192, and 193 to 256. Let me get rid of my math here. And I like to have a dry erase board like this, just because I can do quick math. I don't have to be like typing on a keyboard or hunting around or whatever. Blah, blah, blah. So you plan to add 2 new VLANs, 5 and 6. VLAN 5 should support 46 hosts. VLAN 6 should support 27 hosts. Which of the following answers makes sense? For your answers, simply give the letter of the correct choice. All right, so does it make sense for option A, number 6, 192.168.0.244? Let's see what space that occupies. It is got a .224, 1, 2, 3, 1, 2, 3. All right, so they want VLAN 6 to support 46 or to support 27 hosts. Now, with a subnet mask of 224, it has a block size of 32. So you got to subtract 30. That is doable, okay? And it would range from what is the range that it exists in? So we go up by 32s, 128, 192. 192 plus 32 is 224. So 224 to plus 32, 6 to 256. All right, so option A would be a range of 224 to 256, block sizes of 32. That seems to make sense. All right, let me look at option C. So option C is 192.168.0.189. Again, with a block size of 32, and it also kind of seems to make sense, but I'm not sure. All right, and then let's see, we'll look at D. So D, we want VLAN 5 to support 46 hosts. So for a 192, it would support 64, it would support 62 hosts. And its range would be so I think what we want to really do is like further delineate or further break down the VLAN 4 subnet, which originally goes from 193 to 256. Now, we said that option A goes from 224 to 256, so that would do that. Now, option C, and we already canceled out option B. Option C would kind of fall between VLAN 3 and VLAN 4 because the range of, first of all, for option C, the block size is 32 again. No, yeah, it's 32 again. And it's got a IP address of .189, which actually falls in the range of VLAN 2 already. That doesn't seem to make sense because it's like not adding on to the end. And then finally, it kind of falls in between. Would we want to further break down, and I don't know if we were to further break down VLAN 3 using option C, if we would have the number of hosts available to us that we want, because we need 27 hosts for C. And would we get that if we broke up VLAN 3? Possibly, but I don't think so, given that .189. I don't think we would do it. We would. So where's the block fall? So we need to do, what's 192 minus 32? 192 minus 32 is, so from 160 to 192, give us 32 hosts. So there would be 27 hosts that could fit in there for VLAN 6, but it just doesn't seem to make sense because it's not like tacked on. It's not sequential. All right, so I'm going to go with that. It's not sequential. I'm going to eliminate C. Could be wrong, but we'll find out. And of course, this is clearly taking a lot longer than it would. I would need to be better than what I've done so far for the exam. So just thinking out loud. All right, next up, why or why not for, let's see. So first of all, VLAN 5 needs to support 46 hosts. And so it's got a 192 subnet mask, which is the smallest one it could have. Oh wait, no, yeah, sorry. A needs to support now I'm thinking between A and D. 192.168.0.247, 255.255.255.192. So it's got a block size of 64. And it does get tacked on. So 256 minus 64. What is that? 2. One 192 to 256. So basically, this option D, it just like reiterates VLAN 4. So I don't think that makes sense either. I'm leaning toward A. And I'm kind of like rambling on about it, but that is the feeling that I have. Like, this is the same as this. It doesn't break it up any further. So I don't think that makes sense. All right, I'm going to try A, and we'll see what happens. And if not, hopefully we get a thing, explanation, and we'll do some more. All right, so A, submit. Oh, not correct. All right, show answer. The answer is B. Oh my gosh. Okay, why? All right, so make sure the subnet mask provides a large enough block for the needed hosts. Once you find the needed net mask, make sure that the possible IP addresses is not within any of the previously existing networks. All right, so all of the other options are in previously existing networks. I was like under the false impression that I wanted to like further break down the final network. I like how I immediately got rid of the only correct answer. So again, make sure that the subnet mask provides a large enough block for the needed hosts. Okay, so we needed to, first of all, with a subnet mask of .192, that would provide a block of 64 hosts. And that is the smallest possible block that would work, so that makes sense. And we needed to basically start a new subnet mask, start a new subnet with increment in the third octet there, because all of the space was already used up. 0 to 128, 129 to 192, 193 to 256. 0 to 256 is the only available space. And so I should have seen that it was all used up and we had to move on to the next set. All right, so what I would do now, like I said, is click I only want this type of question and go to the next one. Now we're going to get a brand new question, same type, and see if we can run through this and get it right this time. This is how we learn, and it sucks to get the answer wrong after so much thinking, but it's part of the process. All right, so next up, the following shows a router on a stick scenario. Given the partial show run command information, all right, so first thing I'm going to do is figure out how much space is already used up. All right, so for the first one, .128. Okay, so this range for the first subnet space is 192.168.0.0 so 0 to 128. All right, 0 to 128, because with a subnet mask here in the fourth octet of 128, which I note on my little thing here, I go by the top row where that falls to get my block size. And for a subnet mask of 128, block size is 128. Number 3, again, 129. So we start on 129, and we've got a block size of 128 again. 128 plus 128 is 256. Okay, so that means that all of the 192.168.0 subnet is used up. There's nothing remaining. All right, so we can't use any more of it. We need to create a different one. So that's what happens here. 192.168.1.1, and it's got a subnet mask of 128 in the fourth octet. So that means our range is 0 to 128. All right, I need to create 2 new VLANs, VLAN 5 and VLAN 6. VLAN 5 should support 77 hosts, and VLAN 6 should support 57 hosts. Which of the following answers makes sense? All right, so first of all, we know that we're not going to be in the 192.168.0 range, because as we just said, these two used it all up. All right, and we don't want to break it down further. They're all used up. Okay, so we need to be in a different subnet. Now, we might assume, because we're in the .2 of the third octet in this case for option A, that, you know, VLAN 5 occupied the other half of the space still available after VLAN, or after, you know, interface 4 took up the first half, the first 128 hosts. There are still another 128 hosts remaining. We might presume that 5 took those up for that subnet, and now we've moved on to the first the first 64 hosts of the next subnet, 192.168.2 network address. So I'm going to go ahead and go with A again. I think that makes the most sense. Let's see if I'm correct. Submit. Yes, so that's the correct answer. All right, now feeling a bit more confident, let's do it again. This is how I do this. I just keep going through these until it's very clear what we need to do. All right, so same process. And in the future, I will do a router on a stick course, or a route not a course, but there's some challenge labs that I still need to do. And I'm familiar with router on a stick, but I need to get better at it. So I'll do something like that. It's an important concept. All right, next up. So for interface 1.2, what do we got? What is the range that we have? So we are in the fourth octet again, a .128. All right, I'll put my little tick mark on the 128. And that means that our range is 0 to 128. All right, so available space for IP addresses is 0 to 128. That's what that means. All right, for number 3, we've got a .192. So that means 2 tick marks down, 2 tick marks over, and that's going to give us a space of 64. So we're going to go from 129 to 129 plus 64. What is that? 129 plus 64, that's a 9, 10, 11, 12, 13, 6, 7, 8, 9, 193. Yes. Oh, I see. Well, 120, actually, I'm actually incorrect. This is 0 to 127. The next is 128 to 191. Yes, I think that's right. And so the next, again, 64. So that's, I'm looking at this fourth one here. We've got a 192 subnet mask, which is a 64 size block of space available. And we're going to be, the range is 192 to plus 64. That's going to be 256. All right. So the first 3 interfaces belong to, they occupy all the space of the 192.168.0 subnet. And what that tells me is that anything we add is going to need to go up in the third octet. And that's exactly what I think we see here. So there's no remaining space in the third octet. And again, I would just say, I know that I'm like using this terminology probably not exactly right. So if you are watching this and you recognize that, please just let me know where you spot mistakes or inefficiencies, or yeah, especially inefficiencies in thinking when it comes to stuff like this. Because I know that especially for stuff like this, there's like often very easy ways to do things that I'm just not there in terms of recognizing them yet. All right, so let's see. For the 5th subnet, let's at least confirm, okay, we believe that we need to go up in the third octet, which we've done, 192.168.1, and it's going to have a .224 subnet mask, which in that case, I go down 3 to my 224 on the left side, which means I need to go over 3 to my 32 on the top, 32 being the block size. And so VLAN 5 requires 16 hosts, and that is the smallest block size to achieve that. Now, you might be asking, like, why don't we do a .240 subnet mask and have a perfect match of 16 block size? And that's because you always have to subtract 2, one for your network address and one for your broadcast address. And so your available host size or space is always -2 from what you see above here. And therefore, we wouldn't have 16 available hosts in that case, which is why we need to go up to the next block size, 32, which would give us 30 available hosts. So I believe that A is the correct answer for all of the blabbering that I just mentioned. And I'm going to go ahead and see what we see. Submit. Yes, the correct answer is that. All right, so I feel comfortable with these now. I'm going to move on to a different style question. All right, so What is the maximum valid hosts one will have from the network 192.168.190.0 with a subnet mask of 255.255.255.248? All right, so again, we just do our quick ticks down to 248 on our little cheat thing here, and then over. So I've got 1, 2, 3, 4, 5 ticks down, 1, 2, 3, 4, 5 ticks to the right, which gives us a block size of 8. What is the maximum number of valid hosts one will have from the network? So we've got a block size of 8 for a 248 subnet mask, and valid hosts are that block size minus 2, because again, we have to subtract 1 for the network address and 1 for the broadcast address. So the available valid host space is that minus 2. So I believe the answer is going to be 6. Maximum number of valid hosts, 6. Come on. Yes, the correct answer is 6. So that's wonderful. All right, there are 2 to the h minus 2 usable hosts in a network where h is the number of hot bits. Let's see. H is the number of hot bits. How many hot bits do we have? 1, 2, 3, 4, 5. 2. That doesn't seem right. I think hot bits is host bits, which is probably 3. So 3 to the 2. No, 2 to the 3. Minus 2. So 2 times 2 is 4 times 2 is 8. Minus 2 is 6. So that's one way to get it. You would add up the remaining host bits, which is the ones not occupied by the network address. And then you do 2 to that number of host bits minus 2. Or this speedy little graph just gives you the answer. You just have to subtract 2. So feels good to get that answer correct as quick as we did. If something came up like that on the exam, I think I would knock it out in a couple seconds. All right, let's see what we got next. What is the maximum number of valid subnets one will have from the network 192.168.147/17? Assume this is a class B address. All right, so /17. So that means we're going to be taking a chunk of the third octet. We're going to be borrowing 2 bits from the third octet. So I'm going to do that. And that means our block size is 64. All right. Now, I believe to get the number of subnets, we just need to say 2 to the number of network bits. So maybe 2 to the 2. 2 to the 2 equals 4. And I say 2 to the 2 because we've got 2 network bits. If we were looking for valid hosts, it would be 2 to the number of host bits on the other side that are empty over here. 2 to the number of host bits minus 2. But we're looking for the number of valid subnets. So let's see. 4 valid subnets. Now let's break this up. So if we have block sizes of 64, we would have a range from 0 to 63, 64 to 128. I'm feeling good about this. Sorry, 64 to 127, 128 to 191, and 192 to 256. All right, and that is 4 blocks, so 4 ranges, 4 subnets. I think the answer is 4. So we can arrive at that in various ways. Let's see if I'm correct. That is not correct. Damn. All right, let's see the answer. The correct answer is 2. I think this is wrong. I think this answer is wrong. there are 2 to the x subnets in a network, where x is the number of borrowed subnet bits. All right. Well, we borrowed 2 bits from the third octet. No, shoot. We didn't. It was all wrong. Why? I can tell you why. The first 2 octets have 16 bits. We only needed to borrow 1 bit from the third octet, not 2. So borrowing 2 bits led us down this whole path, and it was incorrect. And that's something I've done. It's got to be just like the simple math can get you. 16 plus 1 is 17, not plus 2. All right, so I'm just going to work through this again real quick. Tricky. Now, if it was a /18, all of this would have made sense. And I think the calculation was correct. It is 2 to the 2, but in this case, it's 2 to the 1 because we're only borrowing 1 bit. So there are 8 bits in each octet. So that means the first octet here, 172, has 8 bits. The second octet has 8 bits. We are a /17, so we've got 16 bits in the first 2 octets. We need to borrow 1 bit from the third octet to give us /17, not 2 bits. All right, because 16 is occupied in the first 2 octets, and then we need 1 more from the second. So let's borrow 1. That means our block size is 128. And that means our range for available hosts goes from 0 to 127, and then 128 to 256. That is 2 available ranges if you're going by the block size method, which means 2 subnets. Or you can just say, I borrowed 1 bit from the third octet, and my equation is just 2 to the number of bits borrowed, or 2 the number of network bits. 2 to the 1, of course, equals 2. So we understand why we got that now. All right, so I'm going to do this again just to make sure I can do it again. So this time, let's focus on our initial very simple math, which can often, as you could see just then, go sideways. What is the maximum number of valid subnets one will have from the network 172.172.2293.80/19? Assume this is a Class B address. All right, so we've got the first 2 octets occupying 16 bits, 8 per octet, and that means 16 plus what equals 19? 3. We need to borrow 3 bits from the third octet. All right, and now our quick equation is to do 2 to the number of borrowed bits, which is 3, and 2 to the third is 2 times 2 is 4, times 2 is 8. All right, so what that also shows us is if we borrow 3 bits from the third octet, we get a block size of 32. And so essentially, if we take the full block, the full range of available addresses, so 0 to 256, and then we do 256 divided by 32, how many equal parts do we get? And the answer is surely 8. I'm going to do 32 times 8. That's going to be 16, 24, 25. Carry the 1, 25. 32 times 8 is 256. All right, so I believe the answer is 8. Submit. Yes, that's the correct answer. All right, so that's good news. I'm going to do one more just to make sure I've got this, but I believe that I do. And again, the message here, the lesson, is to read and focus on the simple math carefully, because a simple mistake like that can just lead you down the bad path. What is the maximum number of valid subnets. One will have from the network 172.27.92.107/16. Okay, assume this is a class B address. Now this is tricky, right? Because we're borrowing 0. So if we're borrowing 0, it's a /16. So we've used up all the bits of the first 2 octets. We're not borrowing anything else. So how many subnets are available? Valid subnets are available. Well, if we don't borrow any, is it just a range of 0 to 256 and therefore 1? That feels right. I have no idea. Let's see. Yes. Okay, so we didn't borrow any bits. Now is 2 to the 1? That doesn't make any sense. I don't know. In that case, does the equation work? It's supposed to be 2 to the number of borrowed bits, but if you borrow 2 to the 0 is 0, right? I don't really know. But what it does mean, I think, is if you just think about the block size, if you didn't borrow any of the block, the total block size of 256 hosts, you've just got that one block. I'm going to do another one. That is kind of an esoteric one, I think. That's an interesting question. Next. What is the maximum number of valid subnets one will have? Blah, 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 blah. Okay, and this is a class C. So this one's a little bit different because it gives us a subnet mask. So I'm going to go down to 252 on my little cheat sheet here. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. All right, so we are in a class C address. So we borrowed 6 bits from the 4th octet. All right, we borrowed 6 bits from the 4th octet. And now essentially the number of subnets is either going to be 256 divided by 4, and that will give us the number of 4 host blocks in 256, the number of available subnets. Another way to do it is, well, first of all, let's figure that out. Okay, so I think it's going to be 64. All right, so I believe the answer is 64 because 256 divided by 4 is 64. Another way to do it is count up the borrowed bits, which is 6, and then we do 2 raised to the 6. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 times 2 equals 4, that's 1, times 2 equals 8, that's 2, times 2 is 16, times 2 is 32, times 2 is 64. 1, 2, 3, 4, 5, 6. All right, so let's try that. 2 to the 6 is 64. That means the number of valid subnets is 64. Submit. Yes, that's the correct answer. All right, I'm going to do one more and then I'll probably wrap up for this session. All right, let's see what we got. All right, here we go. Let's do this. Erase all this math. Following shows a network with 2 subnets. A device on the network is misconfigured. Select the letter of the device which has an invalid IP address. your answer should simply be the letter of the device. All right, so we've got two subnets, one defined by this and one defined by this. So first of all, let's figure out the range of valid addresses for each subnet, because remember, we need to have an address for the network and an address for the broadcast that can't be occupied by any device. So that's probably what's going to be the issue here. So first of all, the range. So a /25. So we're operating here in the 4th octet. We are borrowing 1 bit from the 4th octet here. All right, and so we borrowed 1 bit from the 4th octet. That means our range is going to go from 128 to 255 for this first subnet, the red one. 128 to 255. So we've got .129, which I think is valid. .165, which seems valid. .147 seems valid, because we've got a block size of 128, so 128 plus 128 is 26, okay? And .1. All right, so none of these addresses seem to occupy the network address or the broadcast address, and they are all within the range of 128 to 256 or 255. Next one. So I see the answer. I think I see the problem already. So in this one, we are operating again in the 4th octet. We're borrowing 2 bits from the 4th octet, which gives us a block size of 64. And we're going to go from 0 to 63. Okay, so the very first address, .0, is invalid because this device is occupying the first address in the range, which is reserved for the network as the network address. So I think that's going to be the issue. Let's look at the others though. .24 seems to make sense. It's in the range. .27 is in the range. .5 is in the range. And they don't occupy the broadcast or network address. So I'm going to say the answer is A. Let me just do that. Come on. Yes, that's correct. So what do we do for these? We find the block size and make sure that all the IPs fall within that block size, which is what we just did. Then make sure no broadcast and network addresses are being assigned to hosts. Remember, the usable hosts are those between the broadcast and the network addresses, the network being the first address, the broadcast being the last address in the range, in the block size. Okay, that is enough for tonight. Thank you again to everyone. We are up to 5 subscribers, which is very exciting. And if you enjoy this, please continue to follow along. I'm trying to do like 2 a week. But again, I'm just sort of documenting my learning as we go, especially when it comes to networking. That's a fundamental skill that I'm really trying to improve upon. And I find it very interesting and very fun. I love these little challenges. And again, if you're new to the channel, these videos are, the spirit of all of these is to go through challenges, labs that I haven't seen before. So I'm just working through with you all. And my goal is to just talk it out, speak about what I'm seeing or what I'm thinking, and try to work it out, and fail, try again, fail, try again, which is what you saw happening in this video. Thanks to the creators of subnettingpractice.com. I've got work to do, but I'm starting to get better. And I remember when I first started on the easy versions, the basic subnetting practice, it was like so cryptic. I had no idea what was going on, and now I'm starting to get the hang of some of it, not all of it, but anyway, I hope that was apparent. Thank you, everyone, and I'll see you on the next video. All right, have a good night.